Hello everyone, I'm Aurélie Baker from the ESAVIC South France. So ESAVIC is an incubator promoted by the European agency and managed by Aerospace Valley, a French cluster in aerospace sector. And we are glad today to welcome Anywaves and Capet. ESAVIC South France exists since 2030, and we have a lot of alumni, and we decided to run a series of webinars to highlight our alumni. And today we are delighted to welcome Anywaves and Nicolas. So Nicolas, I give you the floor.
Thank you, Aurélie, and good afternoon, everybody. I'm very happy to be here today to give this speech. Definitely, I'm going to talk about Anywaves and what we do, and where we want to go. But in addition, I think I will try to give you some kind of testimony about how it works from our very beginning, starting with the ESAVIC incubation, which was definitely a huge experience and excellent opportunity to consolidate the project, the overall project, obviously on technical aspects, but not only. So I will try to give you as much as possible feedback on what we lived, but maybe before telling that, you have to know that what I'm going to say is definitely applicable to Anywaves, but sometimes other solutions are needed for other projects. It's just a simple testimony, what we do, what happens during this almost 4 years now since the creation of Anywaves. So to start a little bit of history, so I'm coming from the technical side. I made an engineering school at INAC, French National Aviation School, then a PhD at ONIRA, which is the French Aerospace Lab, and then I joined the CNES in the antenna department during 8 years. So I was in charge of many subjects, both on some big programs with major MOD like Airbus, Thales, but also managing a lot of different activities in terms of innovation, looking for new technologies that are able to be applied to the space. And so in 2017, seeing the emergence of the new space markets and the lack of solution in antenna, I decided to leave the CNES to create Anywaves, both to propose new solutions, new equipment, new antennas more adapted to this market, but also to I would say use some technologies I patented when I was at CNET. And so the history of Anywaves began. How it begins? So first with an ESA pre-incubation we made in Redu. It was a very interesting experience because it was the very beginning of the project. I had a first business plan, the first idea on what I wanted to do, what I wanted to propose also to our customer in order to make space more usable for everyone on the planet, making more good products available all around the world. And then after this pre-incubation, which allowed me to, I would say, have a first version of our business plan and how starting from a white paper, how we are going to build a new company and new set of solutions. And so I applied, it was pretty natural, to ESAVIC. We were incubated in Toulouse, in Théogone Incubation Center. And this was a huge opportunity for us, because when we applied to that ISABIC incubation, we had to face a lot of experts in many domains: intellectual property, financial, technical, lawyers, etc., business developers, and it was the first, I would say, first opportunity to being challenged, to have the project challenge, because obviously all entrepreneurs are here to develop and propose new solutions, to answer new needs. But obviously also, because the reality is there, it has to be economically viable, and there are also many traps you can felt in. And so during this incubation, we were very lucky, having a lot of expertise around us to make, I would say, our life a little bit easier, and also avoid some trials, make good relationships, and so start the adventure of developing a new company. So it was, I said, in 2017 in Theogone, after being accepted by ISABIC. And then I started to develop the company during 1 year, buying the first equipments, recruiting our first collaborators, and going to our first customer, a step which is very, very important. Because at the very beginning, you have an idea, okay, but you have to test, okay, because the solution you are proposing, is there anyone who want to buy it? And the real question also, how much they are ready to pay to get that solution. It was a very interesting beginning, because at this stage you have to find potential customer, trying to convince them, even if you are very young, which is something that can be very difficult, especially in space domain, because space is complicated. You have a lot of technical issues in terms of technology, in terms of qualification, in terms of quality, etc., etc. And especially when, in our case, we develop antennas that are definitely key equipments for satellite, because if the antenna is not working, you cannot communicate with the satellite, so the whole platform is lost, and so your customer is going to be pretty, I would say, unhappy. And if you want to, I would say, to develop in space, it is something that you cannot allow. You have to provide equipments that are going to work during the full lifetime of the mission. And this equipment also is definitely a major contributor to all the radio frequency links, the radio frequency payloads, when you use it in terms of performance, because having a good antenna can allow you to reduce the power consumption on board, which is definitely critical, especially on the markets we address, the market of small satellite in constellations. And small satellites are definitely, I would say, low powerful. So you have to be very careful on how you design your system, and any watt you can save on your payload, on your platform, is definitely interesting. And antennas are definitely a part of the solution. And so starting like that, we applied then in 2019 to the iLab contest, which is a French national competition regarding all the startup in every domains. And we were very lucky being successful and laureate of this contest. It was a huge opportunity for us, and from both ESABIC and the BPI France, in our case, we're here to support our very first research and technology development in order to allow us to accelerate our R&D and propose our products as soon as possible to the market. And then at the end of the year, we had our first antennas in orbit. It was the same launcher, but 2 satellites were equipped with our antennas. It was both an Emeria satellite named Angels and also 3U satellites named ISAT for the Toulouse University. And definitely this was a major step in our development because this was, I would say, the first time our antennas were used in a real environment, on real mission. And so all our customers were relying on us and on the equipment we provided. The same year also, we were laureate from the FinTech contest organized by Euroconsult. It was also an important recognition for us because obviously Euroconsult is definitely well aware of the space market and all its evolutions. And this recognition also was important for us because in terms of positioning, we assume the fact that we are a pure antenna player, so a pure hardware player, pure antenna player, and now our job is develop an antenna portfolio in order to answer, I would say, more than 80% of all antenna needs for that kind of small satellites and even bigger satellites. In some cases, this recognition was very interesting because when you create a company, so you have an idea, you are convinced that what you are going to propose will answer some needs, will solve some problems. But at the end, customers and also all your ecosystem is going to tell you if you are on the right way, because only when someone wants to buy your solution, it's the beginning, I would say, of a proof that's what you are doing as value for your customer, and they are ready to buy it, to pay for that. And this is a very important step. Do not wait too much, and I would say even don't wait to meet your customer from the very beginning. Even if you don't have your product already available on the market, you have to test it to feel if it answers your customer need, because if it's not, you definitely have to change very fast your approach in order to be successful, because obviously at the end, as I mentioned a little bit before, you have to propose a project that will be in the years economically viable in order to sustain your growth and also, I would say, be a long-term solution for our ecosystem. I think it is something that is especially important in space, obviously because space is difficult from a technological point of view, from an environmental point of view, maybe one of the most difficult domain in which you can develop some solutions. Also, the time to market is quite long because people are not buying just one day when they wake up, okay, I'm going to buy a space equipment on internet. It doesn't work like that. It takes a lot of time, but definitely with the growth of the new space market, we need more and more solutions, and we see more and more new companies that are developing equipments, that are developing software, that are developing platforms, that are developing solutions for launch, etc., etc. It takes time, it's normal. It has to be, I would say, well planned, both from development, technical development point of view, an industrial development point of view also, because it's an important step when you want to propose products. Many mistakes can be done if you lower, I would say, the difficulty to make a product well industrialized, because you need to get a very high level of quality and reliability for your customer in the space domain. And obviously, as a consequence, because it's, I would say, some fuel you need, you have to plan all the financial aspects, the money you need with respect to your ramp up, selling some products to your customer. Also, I would say, have a strategy, strengthen your commercial strategy in order to address your market. And one point I think is important. Once you have find the point on which you have to focus, so the solution you can sell to your customer that answer some needs that are a solution for them, to focus on that and maximize, I would say, the impact of the solution you are proposing, both on industrial but also on commercial side. Never, I would say, underestimate the importance of the commercial industrial parts. Obviously, technical part is important in terms of R&D, but it's an important thing to be aware that all parts of the project are important, and a project can die if you fail on one of these aspects. Typically, it's something that is quite well known in France. We are pretty famous to develop extremely brilliant technical solutions, but we definitely underestimate the commercial aspects of our projects. And if your customer are not aware you have the best solution on the market, they won't be able to buy it to you. So go to see them, promote your products, sell it, and it's almost as important as having a good product to propose to them. And then, so 2020, like everybody, it was quite a particular year due to the crisis we know with the COVID. And I would say for us, it was obviously, like everybody, difficult to work, to practice some work at distance, not being in team. But we were very, very lucky, because what we saw during this crisis, contrary to some other domain like aeronautics, or even worse, if we talk about restoration or that kind of thing, we still had a lot of demand, because I think space projects are typically pluriannual projects. So even if there is such a sudden and brutal crisis like we still know today, the demand is still there. And I think it was, for us, a very good sign and some kind of proof that this is not just, I would say, a fashion effect. The new space market was not only a fashion effect. We are convinced, and I am convinced, that we are currently living a huge disruption in the space domain. Obviously, traditional space systems are still going to live, and because they are very useful for many applications. But with the new space approach and all potential constellations in low Earth orbit, and addressing global challenges, which is very important, since space solutions are the most adapted to propose global solutions to people. the number of demands, the number of projects still in development, still in creation, still, I think is good proof that it's not just a fashion, but we are living something huge, a renewal in the space domain. This is something that I'm convinced is going to continue a lot, bringing new solutions and having complementary systems available to traditional ones. And it's definitely something exciting, passionating, and we are very happy to continue to develop ourselves in that domain and propose even always more advanced solution to our customer. So today we are 20 people. We have manufactured a huge amount of flight model, more than 150. We have delivered more than 50 flight models from the very beginning of Anywaves, and we are still developing many solutions in order to enlarge our product portfolio. And so I'm going to now describe a little bit more what we propose to our customer. So as I mentioned very briefly, proposing antennas is definitely a huge technical challenge. Why? Because historically, big satellites of many tons were large enough in order to embed very big antennas, so very, I would say, high performance, high quality, 15 lifetime for geostationary orbits, etc., etc. But with the arrival of nanosats, CubeSats, and all those very small platforms, historic antenna equipments were definitely not adapted to that new kind of platform for many reasons. First, the size, because that kind of platform are so small that you need to miniaturize all your equipments. Obviously, on many aspects, we benefit from technological advance. If I talk about electronics, that kind of things, we benefit from major developments that were performed for on-ground systems. But regarding antennas, miniaturization has always been a huge subject, because you always have to find a good compromise between the performance and the size of the antenna at the end. Why? Because we have some kind of fundamental limitation, which are the law of physics and the Maxwell equations, the law of electromagnetic, and we cannot do anything we want. So from a pure technical point of view, it's something that is very, very, very complex. Also, there is another point, definitely, that is for us a challenge. And from the very beginning, I had this idea, but now we are definitely convinced about that. It is that we need to be a lot quicker than what was done in the space domain. Quicker in terms of development of new solution, quicker in terms of manufacturing and delivery, and especially for customers that have Constellation in mind, Constellation that are going to be able to allow us to propose values and solutions to their customer when and once the Constellation is put in place. Which means that for our customer, it's a race. It's a race because you need to open your service as soon as possible in order to generate revenue. Which means that in a very short amount of time, you have to produce all the platforms and put it in orbits. Which means that instead of providing few equipments a year, we have to provide tens, hundreds of equipments a year. From an industrial point of view, it is something that is completely different. Because you have to think more in a, I would say, an industrial way. And from my point of view, I would say now the new space in terms of industrial approach is very close to the civil aviation approach, because it's a market where you need tens, hundreds, even thousands of equipments a year, but you need a huge level of quality and reliability, especially for antennas, because there are typically no redundancy in that systems. So it's definitely a critical point, a single point of failure for a whole satellite. And this is something I think is very new in the space domain. So this is the way we are developing our products, both off-the-shelf antennas, because there are many antennas that can be very generic and used by any platforms. And I'm going to detail a little bit what we propose yet. But we still have to keep a very high level of quality and being able to produce a lot more than what was done in the I would say 20 years ago in the space domain. So what we decided to do is to propose a portfolio of COTS products, so components of the cells, very generic antenna products that can be used on any platforms. This was the very first step we focused on. And now, because we are currently proposing 4 generic antennas, still developing new ones, but with these 4 antennas, we start to cover, I would say quite a significant generic needs. And we are also starting to develop more complex, more advanced in the second phase antennas for our customer, antennas that are going to be more dedicated to payloads, because antennas are used in many applications. Can be telecommunications, navigation, Earth observation, anyone you need a radio frequency link. Antennas are definitely a key equipment. So I'm going to start with our first product we propose. It's a S-band telemetry telecommand antenna that is dedicated to control the satellites and to bring also its status when in orbit. It's a link that allow our customer to manage the platform and bring sometimes some payload data to their customer. How we did that compared to our competitors? We decided to develop a very wideband antennas that is able to cover all the frequency bands that can be used in terms of regulation. Compared to our competitors that are using antennas dedicated on very small subbands of the S-band antenna, so which implies you need to know the very specific subband you are going to use for your mission. So you are not able to order the antenna until you don't have the feedback from the IoT on which frequency band you use. And also it leads to a long lead time because you need to adapt on each mission the antenna design. We propose a very generic solution able to perform both in emission and in reception, and that can be used whatever the subband that the IoT is going to propose you to perform your mission, and especially allow the telecommunication and telecom link on your satellite. Also, an important feature we had, so I'm not going to repeat it, but obviously the quality is not something we are, I would say, we want to keep high quality in all our products because we are convinced that in space, it's something that cannot be done having very low cost, very cheap equipment working once over 2 times. It's not something that is viable, especially for our customer. But in our case, especially for the telemetry telecommand, what we wanted to do is to propose a product that has a very wide angle of coverage, because this signal you are going to receive or send to your satellite are the very first signal you are going to send or receive, which means that at the liberation of the satellite, when it can spin, so when it can be in whatever the orientation, because it was not possible for you to give the good instruction to the satellite to start being aligned with the Earth, you need to be able to connect thanks to this antenna. So it's an important feature, technical feature, that we propose with this product. And so 4 antennas were sent in 2019, 2 on Angels, 2 on ISAT, 1 on each side of the satellite, in order to cover the full space around the satellite to be able to connect to it. The second product we have industrialized is an X-band antenna dedicated to telemetry, payload telemetry, in order to provide a high gain, high data rate link from the spacecraft to the ground, especially to bring all the payload data that are the value of the mission. We decided to use X-band because X-band allows us to have a very high data rate, both in terms of bandwidth, but also in terms in gain, with respect to the very small size of the antenna. Typically, it can ensure more than 10 times the data rate compared to the S-band systems. And what we can see is that, obviously, with the improvement of all the equipments on board the small satellite, the needs in terms of bandwidth, in terms of data rates, are more and more present. And what we can see is that people who were performing that kind of thing with historically UHF, VHF, and after S-band, now are moving to X-band, because the quantity of the data we can collect are, I would say, exploding, and we have more and more data coming from a very small platform. So this going to be definitely a challenge in the future years to propose solutions that are able to answer this data rate need. Antennas being a part of that kind of system, but not only, obviously. And so today, this antenna was first used for ISAT in order to bring very high resolution images from the zodiacal space for a scientific mission. Also, in 2020, so last year, thanks to the support of ESA in the frame of NAVISP contract, we win. It was a European call for proposal. We propose a new generation of GNSS antenna that are very, very small in terms of size, which means that we are compatible with one use surface. This antenna is less than 90 millimeter in terms of diameter and around 1 centimeter in terms of thickness. And this antenna is able to cover all navigation signals of all navigation systems around the world. I mean GPS, obviously, but also Galileo, GLONASS, Beidou, etc., etc. This kind of equipment is very generic because all our customers need to operate their constellation, which means that they need to know precisely where the satellites are in order to manage their position, obviously for the mission, but sometimes when it is possible also to perform some avoidance maneuvers. And this one is definitely perfectly suited. This antenna is perfectly suited in order to propose very high accuracy positioning. we definitely believe that this antenna, which is currently unique in our market, we are the first to propose such a high performance antenna with so much capabilities in terms of acquiring navigation signals to propose very high accuracy positioning for the satellite, is going to be a key equipment for many future constellations, for the constellation management, obviously, but even for future applications when we will use satellites information. So we will need to know very precisely the position of the relative position of these satellites between them in order to distribute some instruments, some payloads on multiple satellites. So this one is very promising. We already have a lot of interest on that product and multiple opportunities to go as soon as possible in space. This antenna has been fully qualified during this development. It was a 2-year development, and we are very happy and proud to propose now this product that is industrialized to our customer. And then I would say last one of our cost technology, but not least because this one is also navigation antenna, but this time I would say in terms of performance, it doesn't cover all frequency bands, but only I would say the most used frequency band, which is the L1, E1, and B1 for Galileo, Beidou, and GPS. But this antenna has some kind of specific feature. If you look at the material that are between the two metallic parts, it's I would say some kind of key technologies we are currently developing. So I'm going to tell very few words on that technology, because it was definitely some important points of the project from the very beginning, because we are developing a new substrate technology using 3D printed ceramic materials. And how do we do that? So obviously we are using the state-of-the-art in terms of manufacturing of 3D printed ceramics, but also this is the way we are structuring the material, because you can see on the different pictures, these pieces have a lot of very small holes and bars and that kind of thing. And the way we are able to shape the material can allow us to adjust the electromagnetic properties of the material. This is something that is very convenient for antenna designers, because this is a very good way to optimize the design of the antennas, having this new degree of freedom when you design it, because you can choose depending on what you need, the permittivity, contrary to traditional technologies for which you can just use very few and discrete values of permittivity for your antennas. And this kind of technology is definitely a key technologies in order to miniaturize the antenna, because when you use that kind of high permittivity materials, you are able to reduce the size of the antenna, because you reduce the size of the wavelengths inside the material. So today we have 3 patents on that technology, and we are very proud to propose this first product that is probably going to fly next year already, and that is already available to commercialization. And one important thing also is that with this technology, our antenna products are produced 100% in Europe, because traditional PCB technologies are provided by US companies. having a monopole. And what we saw from the very beginning is that it can be sometimes difficult for exportation reasons, and or make our product available to any customer worldwide. But also because you cannot manage the price, being the leader and almost the only one on the earth. Their price are our price, and we don't have a word to say. So in terms of independence and competition, this technology has also this very interesting features. This is the first product we developed, but we still have a long roadmap in terms of technology, because this is, I would say, the most simple way we can apply this technology. We still have a lot in mind in terms of making the properties of the material evolve even inside the pieces, and developing more and more complex and high frequencies antennas based on these technologies. And one also important thing is that because we are using this ceramic material that is perfectly suited for the space applications in terms of resistance to the environments, radiation, temperatures, etc., we are using one process, one material that we have qualified a first version, and we are going to be able to develop a lot of other products, both codes, but also dedicated products to payloads very quickly, without questioning a lot the qualification status of our technology. And definitely, when you develop space equipment, the qualification cost is a huge barrier, because it costs a lot in terms of time, but also in terms of money, because all the environmental tests are very expensive: vacuum, thermal, vibrations, radiations, etc., etc. So we are definitely convinced that this technology will benefit very quickly of this advantage, and this will allow us to propose very competitive products, both on performance, both on production capability, but also, which is important, in terms of price, because from what we know, we are, I would say, an order of magnitude below in terms of price compared to traditional antennas equipment proposed by, I would say, traditional antenna manufacturers. So four COTS products already available in less than 3 years. From our knowledge, it's something quite unique, because we have already a lot of products in orbit. We have new products in less than 4 years, and we have major developments undergoing for a more complex and more valuable antenna for payload applications. And from the very beginning, we were able to confirm that definitely antennas are used and key equipments in all applications: telecommunication, navigation, radars, Earth observation, etc. And for instance, we are the only pure antenna player in Europe. We saw only one company having the same positioning in US, but mainly working for the DoD, the US DoD. So they are not present or in all other places. But definitely, I would say our success, which is in part due to our customers also, confirms that our positioning, proposing new pure equipment antenna solution, is a relevant one. And a lot of other companies are currently proposing other equipments. It can be solar panel, it can be batteries, it can be computation resources on board, etc., etc. There is a huge new generation of companies proposing experts in a dedicated equipment that is very sensitive for the feasibility of some space missions. It's a positioning that is very interesting, and also this is for me also a clue that our new space industry is under structuration, like we see in a lot of other applications, traditional space with major MOE like Airbus or HB, etc., etc., but also in civil aviation, and where they play the role as a system provider and a huge integrator, sourcing the equipments that are available to perform the missions. And I think this new space market needs us to propose that state-of-the-art equipments in terms of performance, miniaturization, cost, etc., to make space more and more accessible, to make more and more space mission doable, feasible in terms of performance, in terms of values we can bring to our customer and the solution we can bring to this new market, and to face all the challenges space can face to take care of ourselves, but also of our planet, and bring new solutions to with a global approach. So this is the end of my speech. I take the opportunity to thank all the partners and the supports we had from the very beginning, starting from ESABIC, obviously. And if you have any question, I am at your full disposition. Thank you.
Thank you very much, Nicolas, for this presentation. It was very interesting. You're doing amazing things. So if you have questions, please, you can use the chat. Maybe I can go first. About your customer, for now you are working with a French and European partner. Do you wish to have a customer outside of France or Europe?
Yes. Because first, definitely, I would say a single country in space is not a market. If you want to have a sustainable company and making it, I would say, economically viable, you cannot focus only on a single country, because space is worldwide. At least it's the size of a continent in terms of market. So from the very beginning, we started with Europe because we were very few, obviously, and it takes a lot of time to prospect, to meet customers, to work also on your development, your value proposition, etc., etc. But from the very beginning, we knew that our market is a worldwide market. So starting with the European part, it takes us, I would say, almost 3 years to start knowing, I would say, most of people in our domain. And last year, we started our export strategy. Because there are two huge markets in space, US, obviously, but also Asia. And what we decided to do is to start, so it's something quite new and quite different from many companies. We didn't decide to go to US, we decided to go to Asia. Obviously, it was something a little bit difficult last year, and I think almost everybody knew why. But we had the opportunity to go in January in India, so just before, I would say, the global crisis. And we are very proud. A few days ago, we announced that we sold our first antenna to a new space Indian players that is going to develop an Earth observation constellation. And so our strategy is definitely to strengthen our commercial proposition and our market penetration in Asia, mainly focusing on India, because India has always been a huge space nation. not very ambitious if we compare to Chinese and US. But in India, there is, I would say, some kind of huge trends with new players, with private actors, which is something very new in India, where the ISRO was managing almost all the space programs. And a young generation in India that is looking for the stars, that is looking for the solutions that space systems can bring to their population. And this is something very strong that has started now. And they are very, very ambitious compared to a lot of other countries. So definitely, India is going to be a huge space nation in the following years. And obviously China, because something we don't say, or maybe we say, but we maybe not much, because for the second year, China is the country that has sent launchers, the most numerous launchers in the sky, more than US. And the trend is just incredible there. They are investing as much as US in terms of R&D, but everybody knows that when you spend €1 in US, you don't have the same thing than when you spend €1 in China. So it's something huge that is happening, and this is why we decided to focus ourselves to China before US.
Okay, so I have also a question on the chat. So do you plan on designing multiple element antennas in the future, and how does your material ensure the miniaturization in that case?
Excellent question. Yes, definitely we are going to propose new solutions, and in our technological roadmap, we are going to propose antennas that are being able to cover multiple frequency links. So I would say today we call it some kind of multifunction antennas that are able to perform both TT&C, navigation, maybe payload data rates, etc. So depending on the mutualization of the antennas and it can be one wideband antennas covering many frequencies or multiple imbricated radiating elements to do that. Our technology is able to perform both wideband applications, so covering many different links, but also our technology in terms of substrates, having a permittivity very high, allow us to have smaller, definitely a lot smaller antennas, and being able, instead of putting one antenna in one U, to put 1, 2, 3, and maybe 4 antennas instead of one. So this is definitely the trends and the solutions we are going to develop and propose in the coming years.
Thank you. So another one. So the person thanks you for the presentation, and they said you mentioned some context you won, like iLab, for example. But have you already considered to participate to collaborative projects at the European level, like Future Horizon Program, Europe Program, European Space Program, for example?
It's a good question. In our case, and I definitely do not pretend this is what should be done, we did not apply to that kind of call for proposal. For two reasons. First, because at the very beginning, they were quite big, and we didn't have the money to be able to apply to that, because we had to justify we can put €1 for €1 of subsidiary. And the other one is I would say also the success that are very low with that kind of project. And I think why also we did not apply to that, it's because we find customers very quickly. And I decided to focus on customers because we are here to propose solutions to our customers. So our customers are going to be considered first instead of any other opportunities. And this is the reason why we didn't apply to that. Nevertheless, we applied to other, I would say, opportunities. I mentioned some ESA call for proposal, which were perfectly aligned with our strategy, so no question to ask. Also with the French Space Agency and BPI, as I mentioned. Yeah. But definitely at European level, there is a lot of huge opportunities to take. So do not fear to try, because it can be something that can make a difference very quickly.
So I think no more question for now. So I will thank you, Nicolas, for this presentation and for doing this webinar. We will put on our social network the replay, and I think if you want to be in touch with Nicolas, I think we'll be delighted to to discuss with you further if you have some question of this great antennas. I learned a lot of things. It was very nice. So thank you, Nicolas.
Thanks a lot. Thank you, Aurélie. Thank you, everybody, for your time.